Okay, in this podcast we're looking at naming ternary ionic compounds, which means those that have 3 or more elements. Okay, so if we have a ternary ionic compound, we still need a cation and an anion. So if there's more than 2 elements in the formula, we must have a polyatomic ion. So it's helpful to identify what those are in the formulas and circle them. So let's just look at, this is a nitrate ion, it's an NO3. And in fact, this ion is covalently bonded in the ion, but it has a charge. It has a -1 charge. As a group, it has a charge of -1. Just like the nitrate ion, NO2, this whole ion has a charge of -1. Okay, so it's actually a covalently bonded species that acts as an ion because as a group it has a charge. Okay, so for polyatomic ions, there's lots of them. You have to memorize 10, but one easy way to recognize some of those is if I have a carbonate and then I put an H in front, I end up with hydrogen carbonate. Just like if I have H2PO4, this would be dihydrogen phosphate, as opposed to HSO4, which is hydrogen sulfate. So for writing formulas, what we want to do is write each ion. The cation goes first, and the cation is the positive ion. And in the final formula, we don't show the charges, even though we use the charges to figure out what the subscript should be. The overall charge of the entire compound must be 0, which allows us to determine how many of each ion we need. If the charges cancel, we just write the symbols. If not, we use subscript to balance the charges. Okay, if we have more than one polyatomic ion, we need to use parentheses around it to indicate how many we have. If we have a transition metal that forms more than one ion, we need to use Roman numerals to indicate the charge, just like we did in earlier practice. So sodium sulfate would be a sodium ion, which would be a +1, plus SO4, which is a -2. So if I want this to be neutral as a compound, this SO4 group has a -2 charge, sodium's +1, so I'm going to need 2 sodiums. Okay? If I have iron 3 hydroxide, iron Fe will have a charge of +3. The hydroxide ion, as you know, is an OH with a minus charge. So in order to get this to balance to 0, I'm going to need 3 hydroxides. And the way I'd write that is like this, with the parentheses indicating I've got 3 of the hydroxides. Ammonium carbonate. Okay, so this is going to be 2 different polyatomic ions. There's only one positive polyatomic ion, and it's ammonium. So I have ammonium and carbonate. Because this is -2, and the ammonium is +1, I'm going to need 2 ammoniums to make this balance to 0, like so. Okay, so let's look at these. Aluminum nitrate. Aluminum will have a charge of +3, nitrate -1, so I'm going to need 3 nitrates. So the nitrate is here, and I need 3 of them, so this is what my answer is going to be, is C. Copper 2 nitrate. Copper is a +2. Nitrate is a -1, so I'm going to need 2 nitrates. And that formula would be right here, 2 nitrates. Iron 3 hydroxide. Iron is going to have a +3. Hydroxide is a -1, so I'm going to need 3 hydroxides, and the way I'd write that is like this. Tin 4 hydroxide. Tin is going to have a charge of 4. Hydroxide is a -1, so I'm going to need 4 hydroxides, so this A is my answer. So ternary ionic compounds contain at least 3 elements. There must be at least one polyatomic ion, and it helps to circle those when we're trying to identify them. So in this case, NO3 would be the polyatomic ion. Sulfate would be the polyatomic ion. Bicarbonate or hydrogen carbonate would be the polyatomic ion. Okay, so match each set with the correct name. So sodium carbonate is C. Magnesium sulfite is is A, magnesium sulfate is B. So be careful when you're naming, because we have eights and ites, and we also have ides. If you remember, the ides are the non-metallic, non-metal elements. They end in ides. Calcium, this is the bicarbonate ions. This is calcium bicarbonate, calcium carbonate, and calcium phosphate.